Hello everyone, this is Preeti Garg and I welcome you all to my maths classes. Today we are going to start 8.1 of chapter number 8 for class 9th, right? This is chapter 8 quadrilaterals and we will be starting with exercise 8.1. This is part 1 of our video. Now before starting with this exercise, let me tell you what all we have done in this chapter, right? Now the name of the chapter is quadrilaterals, and as I have already told you, what are quadrilaterals? Quadrilaterals is simply four-sided figure that is closed. Any figure with four sides and whose boundaries are closed. Any type of a figure if we have whose boundaries are closed, we say that it is a quadrilateral. We have done many properties of quadrilaterals. That quadrilateral is a parallelogram. Parallelogram can be a rectangle, a square, a rhombus. Then there are other types of quadrilaterals too, which are trapezium, kite, and many more, right? We have also done the sum angle property of quadrilaterals, that there are four angles in a quadrilateral and the sum of all the four angles is 360 degree. Okay. So here we start with question number 2 of exercise 8.1. What question number 2 says? Question number 2 is, if the diagonals of a parallelogram are equal, then show that it is a rectangle. Now what we are given? We are given a parallelogram ABCD. See, we are given a parallelogram ABCD. And it is given that the diagonals are equal, right? And we have to prove this parallelogram as a rectangle. So any parallelogram will be a rectangle when any of or each of the four angles are 90 degree, right? Parallelogram will be a rectangle if any of one angle is 90 degree. So now we start with it. Means main motive of this question is that we have to take any one angle and we have to prove it equals to 90 degree, because each and every parallelogram is not a rectangle, but it can be a rectangle if any of one angle is 90 degree. Okay. So as I have told you, the steps that we have to follow for doing such questions are, we will be writing given, then to prove and proof. In given, what we are given? Given में what we are given? A parallelogram ABCD in which AC is equals to DB. Right? AC is equals to DB means two diagonals are equal. What we are going to prove? That ABCD is a rectangle. We have to prove this ABCD as a rectangle. Now we take the proof, and in proof we take triangle ABC and DAB. We take this triangle ABC and this DAB, means to say we take this triangle and we take this triangle. This is DAB and this is AB and C. Now in these two triangles, if we see clearly, AB and AB are coming in both. That means AB is common. Then AD and BC, these AD and BC are the opposite sides of parallelogram, so they will be equal. Also DB and AC are equal. Why? Because they are the diagonals of the parallelogram and it is given to us, right? See, AB is equals to AB, common. AD is equals to BC, opposite sides of parallelogram. Then AC is equals to BD because it is given to us. That means these two, this triangle and this triangle, will be congruent by SSS rule of congruency, right? Now when these two triangles are congruent, this triangle and this triangle, when they are congruent, can we say this angle and this angle is equal by CPCT? Whenever two triangles are congruent, we can take any parts. After proving them congruent, we can take any parts and we can put them as equal. So angle A is equals to angle B by CPCT. Okay. Now just see clearly, suppose we have a transversal here like this. we can also say that these two lines are parallel and this is a transversal here. Then if any two lines are parallel and any transversal is there, then those two angles, the sum of two angles is 180 degree by the property like co-interior angles. Whenever we have two parallel lines and there is a transversal, then two interior angles are formed and the sum of those two angles is 180 degree. So the sum of angle A and angle B becomes 180 degree. But just now we have proved that angle A is equals to angle B. So we can write in place of A, I can write B also. In place of B, we can write A also. So I wrote angle A plus angle A is 180 degree. Then we can find that angle A is equals to 90 degree. Single angle A is 90 degree. So this is what, thus ABCD is a parallelogram and one of its angle is 90 degree. A parallelogram in which one angle is 90 degree. So we say that ABCD is a rectangle. Fine. I hope it is understood. I hope it is clear. Once again, I am telling you the solution. First of all, for proving such questions, you have to follow the steps given to prove and proof. Right? We are given a parallelogram in which diagonals are equal. Now parallelogram, and we have to prove that it is a rectangle. For proving any parallelogram or rectangle, we have to prove one of its angle equals to 90 degree. So we take two triangles and prove the congruency. As we have proved the congruency by SSS rule. So now we get two angles, angle A and angle B, and the sum will be 180 degree by the property of co-interior angles. And since A and B are equal, so we can write A plus A is 180 degree. Hence we get angle A is 90 degree. Fine? Okay.